Gentlemen, welcome to a lesson on scientific notation. The very fun way of working with very large or very small numbers. You guys have probably seen scientific notation before at some point. It's usually some number, call that m, and then there's the multiplication x, and then 10 to an exponent of n. Alright, for example, we could have 1.25 times 10 squared. That would be a number in scientific notation, and so would like 3.61 times 10 to the negative fourth. And like I said, you've probably seen these before somewhere in math or in bio or in some other science, but it might have been a little while. You might be a little rusty, which is fine. That's good. Couple of ground rules for this. That m, that first number there, has to be greater than or equal to 1. It can never be less than 1. But it has to always be less than 10. So you're going to have one digit and then a decimal each and every time. If you look over here at the two examples, all right, I have 1 and then a decimal. And in the second example I did earlier, I have 3 and a decimal each and every time. And then the exponent n is an integer. An integer is any positive or negative number that is not in the decimal place. It's any positive or negative whole number. It'll be anywhere between negative infinity and infinity. It has its own number, and then there's a positive sign or a negative sign. And the easy way to get from scientific notation back to numbers that you know, if there's a positive n, you have to move the decimal place in the number before the times 10 to the right. If it's a negative m, you move the decimal point to the left. So 1.25 times 10 squared. If I look at this and I move that decimal place to the right, it goes to the 2 and then it goes to where the 5 is. I get 125. All right, now 125 isn't a very large number. I'm just picking a nice small number here to kind of help you see the whole process. You know, we'll get to the bigger numbers in a minute. Second example I gave you was 3.61 times 10 to the negative fourth. Here I have that negative sign, so I have to go to the left 1, 2, 3, 4 spots. Each of those spots are going to be filled with zeros. I kind of ran out of space there, but what I get is 0.000361, which is a much smaller number. It's a small number, and so we put it into scientific notation. All right, we're going to mosey on and maybe kick it up a little bit of a notch here. The biggest problem that we run into here in chem with scientific notation is using scientific notation numbers in calculators, because at times you will need to do this. All right, one of our big numbers for this unit and for a couple other units and other stuff down the line is a really, really large number in scientific notation. We need to know how to use scientific notation on the calculator. All right, and the thing is, we have to use a special button. Now, each calculator is different, and brands tend to stick with the same format time after time again. If you remember back to the syllabus page, I recommended the TI-30X2S, which is this calculator right here. It can come in a wide variety of colors and all this stuff. So I am going to go through that one for you. The big thing is take out your calculator, kind of take a look at it. If you have questions on how to do it on your calculator, come see me at some point in the near future, because I've seen many of the calculators that you can buy in the stores, so I should be able to help you figure it out. If you have a Texas Instruments calculator that has the word multi-view on it, you've got a calculator that's going to make your life a little difficult, probably, coming to scientific notations, because you have to use parentheses all over the place, and you can run into a problem of syntax errors, which just means you type something in that the calculator doesn't understand. But anyway, the button you do not want to use is the times 10 and then the little caret thing. Now, not every calculator has one of these, but you don't want to use times 10 to the little caret, or really just 10 to the x. Now, when you get to a Casio calculator, there's a times 10 to the x, which you do want to use. It's all confusing. The main reason I pick the TI and the Casio, and I have two pictures of them here, is because of the fact that those are the two that I see the most. And so since I see those the most, that's what we're going to talk about. I'm going to zoom in a second here on the TI. What we're looking for is an EE button. If you are using an iPad calculator, chances are it has an EE button as well. And again, pop in, flex time before school, after school, 5 minutes, and we can work out how to do this. It's an easy fix. You just kind of gotta see where it is first. So, as I go in here, one of the things you can't see too well when I zoom in is where this EE is. And it is actually right there. Alright, on the TI-30X2S, it is right above the 7, which is where it is on most TI calculators, but it is hidden as a second function. So you have to hit second, which is right here. Then the x to the minus 1 to get the EE. And sometimes it'll put in times 10 to the, and then you type in the exponent. Sometimes it'll just give you the letter E, and then you put in the exponent. They kind of mean the same thing. It's just how this ended up getting made. If we slide over to the Casio, the button on the Casio is right here next to the answer button, next to the decimal point. You just type in your number, you hit that button, and you type in the exponent. and then you would hit equal and it would figure it out for you. All right, that's about it. Well, you might need to use parentheses, which on this calculator are right here, if you have this. As if I need to. So what we're going to do now is we're going to practice this converting into regular notation. Okay, converting to regular notation is all about the sign of the exponent. If you have a positive exponent, I probably should have put an X in there. If you have a positive exponent, you move to the right. Negative exponent, you move left. And the number tells you how many spaces to move. So, if you run out of numbers, you add zeros. So this first one, 4.47 times 10 to the third. All right, 4.47. I'm going to move 1, 2, 3 spaces. All right, I have this empty space here. I put in a 0. I have 4,470. 1.780 times 10 to the 5, 1.780. 1, 2, 3, 4, 5. I have 2 empty spaces. I pop in 2 zeros. 178 0 0 0. And I can put in those commas if I need to. If I don't need to, I don't have to put them in. 6.78 times 10 to the negative third. This is a negative exponent, so I have to move the opposite way that I did with the positive exponent. So I got to 6.78. I got to move 3 spaces to the right, to the left this time, sorry. 1, 2, 3. And there's a couple of spots to put a 0. And then I usually put a 0 before the decimal place because it looks pretty. And that's what people like. 0.00678. Here we have 9.721 times 10 negative 8th. I gotta go 1, 2, 3, 4, 5, 6, 7, 8 spaces, and then 1, 2, 3, 4, 5, 6, 7 zeros go in there. Pop that 0 before the decimal, and I had 7 zeros. 6, 7, 9, 7, 2, 1. All right, pretty easy stuff. Now we're going to get to number 5, which is this big number here that we'll see a lot more this year. All right, this is that really big number I talked about. It's 6.02. 0.